Hi everyone, Jason from Makera here with another Carvera tutorial video, and this is actually part one of a two-part video series showing you how to get started with the Carvera Desktop CNC and Solidworks CAM, an extension for the Solidworks CAD program. In this first video, we're going to go ahead and look at how to actually download the Carvera's existing 3-axis profile from our wiki, and then see how to set up the Carvera as a mill with the tool crib and assigning tools and feeds and speeds in what SolidWorks CAM calls its technology database. So let's dive in and see how to do this.
All right, so after going to the Makera wiki site, you can go to the software page and then scroll down to the different machine software until we find SolidWorks CAM. There, you can go ahead and download the profile and then unzip this file in your downloads folder. Here you will find two files that we need to copy to where SolidWorks stores our machine profile. So I'm going to copy these files and then in another tab, navigate to this path. And this might vary on different devices, but typically we can find this under your C drive, program files, SolidWorks Corp, SolidWorks CAM, and then TechDB app. And here I'm going to paste those two Carvera profiles. Once those have been pasted here, we can go ahead and launch SolidWorks. After launching SolidWorks and going to the SolidWorks CAM tab, you can click the Technology Database button to launch the Technology Database app. And this is where all of your machine and tool and feed and speed settings can be set prior to creating any projects in SolidWorks. And the first thing you could do if you couldn't find the program file folder to put those Carvera profiles is head over to the settings button, and this will show you where all your program files should be stored for the technology database. And here's the path that I had gone to add my Carvera profiles. Now, the first thing we're going to do is actually create the Carvera as a mill. So we're going to click on the mill metric default, and then we're going to copy this to create a new mill metric copy. Here, I'm going to go ahead and select this as my default machine, and I'm going to rename it to be Carvera 3-axis. It's a milling machine, and I can call this Carvera Desktop CNC by Makera as a description. And then the post processor, we're going to change this to be the Carvera 3-axis post processor, which you should see that as an option if you've successfully added those profiles to the right file location. Then in terms of the duty, light duty, medium, heavy duty, and heavy duty, this is the default feeds and speeds, and we'll get into that in just a moment. But I typically find that the Carvera aligns most with the medium duty feeds and speeds in the default profiles. Next, we can adjust our different specifications. You don't have to worry about horsepower, things like that, but you can control your max feed rate that we're going to do. Typically, your max feed rate wouldn't exceed more than 1,000 millimeters per minute, but it depends on what it is that you're going to do. And your rapid feed rate, that shouldn't exceed 5,000 millimeters per minute, but we're going to lower that to 2,500 millimeters per minute as a good safe default. But you can fine tune this based on our operating parameters as you see fit. For our X travel, we can change this to 360 millimeters. Our Y can change to 240 millimeters. And our Z can change to 140 millimeters. We have a sequential tool changer, and the tool crib that we're going to use will be set later. So at the moment, it does not matter which tool crib it is that you choose. We're going to end up changing this in just a little bit. But one thing that you can do is change the amount of time it takes to swap the tool, which last time I checked was about 40 seconds or so. And this, of course, doesn't change the overall performance of SolidWorks CAM or anything like that, but it will make your approximate time more accurate when you actually generate your tool paths. Next, our max RPM for the spindle is 15,000 RPM, and you don't need to adjust any of the other settings, so we can go ahead and press save. All right, so we have our mill created. Let's head back to the mill menu, and now we need to talk about our tool crib. So let's click Tool Crib 1. And the tool crib is essentially your collection of tools, and this would correspond to the tool changer in the Carvera. So we're going to go ahead and create a new tool crib, and we're going to call this Carvera Example Tools. And we're going to set this to have 6 stations, which matches the 6-place tool changer in the Carvera. Now, we'll go ahead and add tools to this later, but if we head back over to our Mill tab and click on the Carvera 3-axis, we can then scroll down to where it has tool crib and choose Carvera example tools as our default tool crib, then hit save. So now anytime you select the Carvera 3-axis, it will also select your Carvera example tools. Now, in terms of tools, let's head over to our mill tooling menu. And you can see that SolidWorks has a number of tools already preloaded. So if you click on any of these categories, like a flat end mill category, you'll see that there are loads of tools here that you can work from. And it's pretty easy to go ahead and create a new tool, but I like to actually copy one and modify it. I find that to be a little bit easier. So for example, I'm in my flat end mill tool library, and I'm going to pick a tool that's close to the size that I want, like for example, this 3mm tool, and then click copy. And it's going to go ahead and create a copy right here down in this category. Now I'm going to rename this tool, and I like to put EX here because it's my example tool from the Carvera default example tools. And I'm going to rename it to be a example 3.175mm by 25mm single flute end mill. We can use it for roughing passes and finishing passes. I always select that because if you don't, SolidWorks CAM won't automatically select this tool for you or won't actually let you use it for a type of tool path. It's a straight shank with a diameter of 3.175mm. Its shank diameter is also 3.175mm. Its overall length is 45mm. Its flute length is 25mm. And you'll see I'm getting an error message here because I have to adjust the shoulder length first. So the shoulder length and the protrusion length are both 33mm, and then I should be able to adjust my flute length because, of course, the flute can't be longer than the protrusion. So there we go. Now, I pulled these numbers off of our database on Makera.com, but you can also, of course, measure your tool to find these numbers, and SolidWorks CAM gives you this nice little graphic here that you can see. The protrusion would be what falls below the bit collar on your Carvera tool. Now, this is only a single flute, so number of flutes is 1, and I'm just going to rename the comment to be Carvera example tool. And then down here we can do speeds and feeds. Now you'll notice that SolidWorks defaults to the surface meters per minute, which is a unit that can be used for calculating your spindle speeds. And you can certainly use this, but all of our feeds and speeds and what we have on our wiki is based on the spindle RPM. So you can always uncheck this box and then manually set the spindle RPM. And there's a way to set speeds and feeds for the actual tool or for the material, and we'll look at both. But I like to set the defaults for the tool based on our typical cutting parameters. So I'm going to typically use this tool with a 12,000 RPM spindle, and I could always adjust this later for a specific thing. My XY feed rates are typically 500mm per minute. My Z feed rate for this tool is typically 200mm per minute, and my lead-in can also be 200mm per minute. In terms of coolant, no coolant is needed, so we can say off. And yes, you could still use the air assist, but that would be adjusted later in the Carvera controller app, not in SolidWorks. So we can go ahead and press save. Now that I have this tool, I'm going to go ahead and copy it. And I'm going to turn this into our 3.175 by 12mm single flute end mill. That's also from our samples kit. The overall length of the 12mm bit is 38mm. My protrusion length for the 12mm bit is 26mm. So I'm going to change my protrusion on my shoulder. And then my flute length for the 12mm is, of course, 12mm. All my other settings are going to remain the same. So once you have one tool that's in the ballpark of what you're looking for, it's pretty easy to adjust and add more. And also within our examples guide is our 0.8mm corn bit. So let's go ahead and duplicate this guy one more time. SolidWorks CAM does not have a corn bit category, so we can use the single flute or the flat end mill section for our corn bit. So I'm going to rename this to be EX. This is a copy now. I'm going to rename this to be EX 0.8mm corn bit. Our diameter is 0.8mm. Our shank diameter is still 3.175. The overall length of the corn bit is 38mm. Our protrusion and our shoulder length is 26mm, but our flute length for the corn bit is only 6mm. We can also change this to have two flutes rather than a single flute. And down here for our feeds and speeds, I would typically use a slower XY feed rate but my Z and my lead-ins and everything like that can stay here as a default. And again, you can find default feeds and speeds on our wiki. All right, let's go back to mill tooling and let's choose a different category. Also within our example guide is a V-bit or an engraving bit. And there isn't an engraving bit or a V-bit category, but we do have a taper end mill category down here. So we're going to go open up the taper end mill category and let's go ahead and just duplicate this first 2 millimeter tool. So I'm going to copy this, and then we can go ahead and rename this to be EX 0.2 millimeter engraving. Shank type is straight. Our end diameter will be 0.2 millimeters. Our shank diameter will 3.175 millimeters. Our taper angle will be 15 degrees, which is what gives us our V-bit. The overall length is 37 millimeters. The protrusion and shoulder will be 25 millimeters. And the flute length for this is 10 millimeters. Number of flutes would just be 1. I'm then going to adjust the comment and change this to Carvera example tool. Then down here, we're going to adjust this for our spindle speed of 12,000 RPM. My XY feed rate is going to be a little bit on the slower side, so I'll go 300 mil. My Z feed rate is going to be a little bit slower as well, so I'll go 200. And my lead-ins are going to be slower, so 100. My coolant can be off, and we can press save. Now we have our V-bit. Let's go back to our mill category, our mill tooling, I should say. And then let's head over to countersink, and we can use countersink to create our chamfering bit. So I'm going to choose a countersink bit here to use. So we'll go ahead and copy this first one. Let's go ahead and make this active so we can select it in our tool crib. And let's change the tool ID to being EX 45 degree chamfer to match the default tool. Size designation is going to be 45. Our diameter is going to be 3.175. Our end diameter is 0.1. The shank diameter is 3.175. Our countersink angle is 45. The overall length is going to be 38, which I can't do just yet. I'm going to adjust my protrusion first. So the protrusion and the shoulder is going to be 26. Then I should be able to go back and set my overall length to be 38. Number of flutes for this is just 1. Tool material, we can change this to be carbide. I'm going to rename this to be Carvera example tool. And down here, we can adjust our spindle to be 10,000 RPM, our Z feed rate to be 200, and coolant to be off. So that encompasses all the tools in the Carvera example kit. But let's go ahead and add a drill bit, just so you can see how to do drill bits. And while it's not in the example toolkit, the Carvera does come with drill bits. So we'll go to our mill tooling and then the drill category. And let me see if I can find a small drill bit like this 3.2 mil. Let's copy this. And I'm going to stick with the same naming scheme here. So we're going to call this example. And let's turn this into a 2 millimeter drill, which comes in a lot of our kits that we use for a lot of things. So size 2 millimeter. The diameter is 2 millimeters. The shank diameter is 3.175 millimeters. Our overall length for this bit is 40 millimeters. But let's go ahead and adjust our shoulder length and our protrusion. The flute length is 12. The protrusion is 28. The shoulder length will be 28. And then we can do our overall length of 40. Number of flutes would be 2. The tip angle will be 118 degrees, and the tip length of 0.6 millimeters is perfectly fine. For our material, we're going to switch this to be HSS. And comment, we can call this Carvera example tool. Down here, spindle speed for drill, we usually do 10,000 RPM, although of course that can vary a little bit based on material. Our Z feed rate, I like to do something on the slower end, like 100, and we can turn off cooling. All right, so we just created 6 tools, and hopefully you saw how you can copy tools and find ones that are close, so making tools isn't, you don't have to make them all entirely from scratch. Let's head back over to our mill menu and let's go to our Carvera example tools crib and let's add these tools to the tool crib. So I'm going to go ahead and add them in the order that I'd like to use, although you can renumber them later. So I'm going to add a flat end mill and select our 3.175 by 25 millimeter bit by choosing it and then clicking select. Then right here, station, I'm going to say station 1. So that's where it's going to be in our tool changer. And if we assign this, that means that whenever we do a tool change or a different path later in Solidworks CAM, a tool change will happen automatically. Station ID, I'm going to name this to be the tool. So I'm going to call this 3.175 by 25 mil. And I don't have to change anything else, so I can just push save. And we'll see that we have our tool here. The ID actually comes from the actual library. So that's the ID of where the tool is in your overall tool library. So let's go ahead and add another tool. And the next one we're going to add is our taper bit, or engraving bit. So we're going to select our engraving bit here from the taper end mills. Station for this is going to be 2. Station ID will be 0.2 millimeter engraving. And we can click save. Tool 3 is our corn bit. So I'm going to go to flat end mill and find that 0.8 corn. Set this to be 3. Next, we're going to go ahead and add another flat end mill. This one will be our 3.175 by 12. And we'll assign this to be tool 4. Tool 5 in the examples guide is the chamfering bit. So we'll add our countersink bit, which is our 45-degree chamfer. And this will be tool 5. And lastly, for tool 6, technically in the example guide, we keep this blank for the test probe, or we might put the solder mask removal tool. But in this case, I'm going to select our 2 millimeter drill bit from tool 6. So here's my drill. I can select this and assign this to be slot 6. And we can call this 2 millimeter drill. All right, so now we have created our tool crib. We have our 6 tools, 1, 2, 3, 4, 5, 6. These first 5 match the Carvera example guidebook and the example tools that come with the Carvera. And then, of course, I added the drill where we have an empty slot in the example guidebook. But, of course, you can choose any tools and you can assign them in any order based on the projects you're doing. You can also duplicate or make additional tool cribs, which I find to be easier than reassigning. So if I find that I do a lot of PCB projects or woodworking projects or metalworking projects, I find that I create several tool cribs so I can switch an entire tool crib rather than going in and reassigning or deleting and adding a different tool. Now, because we assigned 6 tool stations, you'll also note that if I try to add another tool, I have no empty stations available. So if I did want to add another tool, I would actually have to delete a tool, like for example, delete tool 4, then go ahead and add another tool and assign it to be station 4. And SolidWorks CAM is pretty clever that way. All right, so we have our mill. We have our tool crib. We've added our tools. Now, the only other thing you might want to consider doing is feeds and speeds. So if we click feeds and speeds, we can open up our stock editors and our feed and speed editors. And I will be honest, this is not something we have time for to do in this video, other than me showing you an overview, because this could be something that you spend hours doing. And if you're going to use SolidWorks CAM and you want it to be as optimal as possible, like its auto generation features, which I'll show you in the second part of this tutorial, then you really want to put in time to set up your feeds and speeds based on materials, so SolidWorks will automatically calculate these things for you. You can always override them later, and we did already create the default based on our tools, which you'll see how to do in the second half of this video tutorial. But it's a good idea if you are going to use SolidWorks CAM to put the time in to make your feed and speeds and your stock exactly what it should be for your Carvera. So how would you do this? Well, let's first click on the default stock material. And you'll see that you have your default stock list here. And you have a lot of different metals, epoxy, things like that. But what if there's something that I want to be working with that isn't actually in this default, right? What if I want to work with styrofoam or acrylic or whatever it is? Well, SolidWorks CAM has hundreds of stock options, thousands of stock options. So if we open up our feed and speed editor, we can adjust our stocks that we have available. So this is the material library and the feed and speed editor here. This is where you can see you have your default materials. If I hit install from archive, I can now browse the thousands of materials that are in SolidWorks CAM and add them to my default list, right? So let's see something that isn't in that I might be using. Let's see. So let's say, for example, I'm going to be machining polystyrene foam a lot because I'm going to use that as a good test material to test out my parts. I can select polystyrene, click Install Material, add it to this by hitting yes. Now, if we return to our feed and speed editor, we'll see that polystyrene is down here in our library. Now, in terms of your feed and speeds based on material, not based on tool, we already did the feeds and speed based on bit when we created our tools, but based on material. So the default feeds and speeds for polystyrene or epoxy or aluminum. That is right here in this feed and speed editor. So the way that this works is in this macro estimating window. You can select the material, and again, this is your default list. So if you're missing a material here, you're going to have to add it like we just added polystyrene. You can choose your operation, so all the different types of operations that you might want to do, whether it's a facing operation, thread milling, tapping, roughing, whatever it might be. So roughing and finish is your typical pockets and contours and things. The machine that you're using, right? So we said that we typically associate the Carvera with a medium duty machine. Your tool material that you're using, and you'll see that the feeds and speeds are automatically calculated. And these feeds and speeds typically don't correspond directly with the Carvera defaults. So I can click on any of these and I can change the feeds and speeds. And remember that this is your surface meters per minute, not your spindle speed. So you'd have to use a calculator to convert spindle speed to surface meter per minute if you're using our defaults. And if I wanted to, I can click on these things like speed or feed and consistently change them by a percentage. So increase them by 10% or lower them by 10% by simply pressing up or down 10%. You'll see that adjusts all of them based on the depths of cuts and things like that. Or again, I can click on any of these and I could manually change what I'd like the feeds and speeds to do as you go. And this is an incredibly time-consuming process and not one that you have to do. When you go ahead and create a toolpath, you can always enter the feeds and speeds manually per toolpath. When you're using a bit and you set the feeds and speeds per the tool, you can always default to your tool. But to really get the most out of SolidWorks CAM, you do want to spend a lot of time setting up your feeds and speeds based on your material, so that way it will automatically generate and do these for you, or really, so that way you don't accidentally use a default feeds and speed, which is way off from what the Carvera should be. So after you adjust your feeds and speeds, you can click Save, or you can click Save and Close. And then for these things to actually take place, so for them to actually happen and be usable in SolidWorks CAM, you have to press this update stock material data and this tool material data to actually push these and update these. And this could take a long time depending on how much you change. So this should only take a second or two for me because I only change one material, but this updates all of the material, all the feeds and speeds, everything for your entire library, all thousands of them, right? So it could take a while depending on your computer to actually push this through and for you to be able to see those changes in SolidWorks CAM.
All right, so now that you have your technology database set, it's time to actually use these resources to create a project using SolidWorks CAM and the Carvera Desktop CNC. If you're interested in seeing how to do that, check out part 2 of our Getting Started with the Carvera and SolidWorks CAM tutorial series. But in the meantime, please don't forget to subscribe, and thank you for watching.